Welcome to this explainer. Okay, today we're undertaking a seriously fascinating journey. We are going to learn how to read the universal map of the human body. If you've ever looked at a medical chart or, just listened to healthcare professionals speak, you might have felt like they were talking in code. And, well, in a way, they kind of are. But it's a code built entirely on strict spatial logic. Specifically today, we're going to put a heavy focus on the anterior and posterior axis, and we'll examine exactly how it fits into the broader context of the directional terms that literally architect our understanding of biology. Picture this for a second. A patient walks in and tells you they have a painful scar above the wrist. Well, where exactly is that? Take a moment to really think about it. If you were a surgeon or maybe a physical therapist, could you confidently point to the exact millimeter that patient is talking about? Probably not, right? This completely vague instruction immediately highlights a massive, high-stakes problem in medicine: the sheer danger of using everyday, ambiguous language when you're dealing with the intricate machinery of the human body.
Okay, let's dive into this. Here's our agenda, which is basically going to act as our legend for navigating the body's geography today. First, we'll cover the need for precision. Second, standardizing the body map. Third, anterior versus posterior. Fourth, expanding the directional compass. And finally, why this language matters.
Section 1. The need for precision, eliminating ambiguity in medicine.
Historically, as medicine evolved from just frantically patching up battlefield wounds to actual formal study, everyday language proved dangerously loose. That's exactly why anatomy relies so heavily on dead languages like Latin. The definitions literally never change. Revisiting our earlier problem for a second, does above the wrist mean 2 inches up the forearm? Is it at the base of the hand, the palm side, the back? Without a foolproof, structured grid, simple phrases cause catastrophic clinical confusion. If a surgeon makes an incision on the wrong side of an appendage just because of a misunderstood chart, the consequences are disastrous. We absolutely need a grid, a coordinate system that is entirely foolproof. Moving right along to Section 2, standardizing the body map, establishing true north.
Think about it like this. Before a cartographer maps out a mountain range, they need a compass rose, right? Anatomy requires the exact same baseline orientation, and that brings us to the anatomical position. This is the universal starting point: a body standing upright, feet shoulder-width and parallel, toes pointing straight forward. The upper limbs are held out to each side, and most importantly, the palms of the hands are facing forward. So the crucial point is, directional terms are always used as if the body is locked into this exact position. It totally doesn't matter if a patient is actually lying face down, which we call a prone position, or lying face up, which is supine. If a doctor describes the front of the wrist, they are describing the palm side, because in the anatomical position, the palm faces forward. The map never changes, even if the territory is moved.
Section 3. Anterior versus posterior, the crucial front-to-back axis.
All right, now we're getting to the absolute core of this explainer. Once the body is locked into that anatomical position, our very first spatial contrast is front to back. Now, what's really interesting here is that these terms are strictly taught as a binary pair. It makes them conceptually sticky. Anterior, which is also referred to as ventral, describes the front, or a direction toward the front of the body. In contrast, posterior, also known as dorsal, describes the back, or a direction toward the back of the body. Just think of a shark's dorsal fin, right? It's right there on its back. This axis gives us a perfect slice right down the coronal plane of the body, allowing us to definitively say whether a structure sits closer to the chest or closer to the spine.
Let's anchor these kind of abstract definitions into a physical, relatable reality. Your sternum, your breastbone, that's a long, flat bone located right at the anterior of the chest. If you look down at your feet, your toes are anterior to the rest of the foot. On the flip side, your spine is completely posterior to your stomach. And your shoulder blades, or scapula, they're located squarely on the posterior side of the body. By mastering just this single axis, you can already accurately map a massive portion of human anatomy.
Section 4. Expanding the directional compass, more axis to navigate the body.
So while anterior and posterior give us incredible front-to-back accuracy, the human body is a completely three-dimensional machine. Let's move along and see how this builds a complete navigational system. Superior means above or toward the head, while inferior means below or away from the head. For example, your eye orbits are superior to your mouth. Next up, we have the medial and lateral pair. Medial just means toward the midline of the body, while lateral means away from it. So your heart is medial to your lungs. And finally, for our limbs, we use proximal and distal. Proximal is nearer to the trunk's attachment point, and distal is farther away.
Therefore, your hand is distal to your elbow. When you combine all of this with anterior and posterior, you've got a flawless 3D grid.
There's just one final pair to complete our coordinates, and this one dictates depth within the structural map. Superficial means a position closer to the surface of the body, like your skin is superficial to your bones. Deep, as you might guess, means farther from the surface. The brain is deep to the skull. If a physician is looking at a puncture wound on the anterior side of the chest, knowing whether the damage is superficial or deep literally dictates the entire medical response.
Finally, Section 5. Why this language matters. The real-world impact of precision. We've spent a bit of time defining terms and plotting out axes, but let's zoom out for a second to the real-world application here. And this brilliantly illustrates our core thesis today. As our sources state, the purpose of this terminology is absolutely not to confuse the uninitiated. It's explicitly designed to increase precision and heavily reduce medical errors. Whether it's a radiologist noting a tumor on the posterior side of a medial organ or a surgeon making an incision on the distal end of a femur, this language ensures absolute, unwavering clarity between professionals. It's a language where ambiguity is totally eliminated, and because of that, it is literally a language that saves lives. To wrap up today's explainer, I want to leave you with a bit of a provocative thought. We usually just think of anatomy as, bones and tissues, but consider this. How does a unified, precise language shape not just clinical medicine, but our fundamental understanding of the human machine itself? By putting words to these spatial relationships, we don't just describe the body, we conceptually organize it. Thank you so much for joining me, and keep exploring the incredible map of human biology.